Absolute value equations. In this section, we'll be going over how to solve equations involving absolute value. So first, let's define the absolute value. The absolute value of x, denoted x inside of two vertical bars, is its distance away from 0. In exercise 1, consider the equation the absolute value of x equals to 3. Now, to emphasize the distance away from 0 part, I'm going to write this as the absolute value of x minus 0 equals to 3. It doesn't really change the problem by adding or subtracting 0, but I like to do it because it emphasizes that the x minus part deals with distance. Because we're subtracting away from 0, we're dealing the distance from 0. The equal sign tells us that what the distance is, and then the 3 tells us the value of the distance. It's 3. So we have the distance from 0 is 3. So if we're starting at 0, what points are 3 away? Well, if we go 3 to the left, that's x equals to negative 3. And if we go 3 to the right, that's x equals to positive 3. So our solutions are x equals to negative 3 and 3. Because those are the points that are 3 away from 0. So if x minus 0 is the distance from 0, then what about the absolute value of x minus 5 equals to 3? Well, you might be tempted to say that we have the distance from negative 5 because of that negative sign, but be careful. What's actually going on is the x minus part tells us that we have the distance from positive 5. And the reason why this is because when we have distance, we want the minus sign. So it's x minus and then followed by the number. And then the equals part tells us what the distance is, and in this case the distance is still 3. So we, in terms of interpreting the problem, we center around positive 5, and we want the values that are 3 to the left. So that's going to be positive 2. And if we go 3 to the right, that's going to be positive 8. So our solutions are 2 and 8. So the big takeaway from exercise 2 is to understand that we want the minus sign, since that's how we define distance. And so you might be tempted to make your quote center at negative 5 because you see the minus sign, but it's actually the opposite sign, positive 5. So in exercise 3, what about x plus 5 equals to 3? Well, notice that we don't have a minus sign for this problem, but we can fix that. Because what we can do is take advantage of the fact that a double negative turns into a positive. See, now that I have x minus 3, or 5, it doesn't change the problem. But now we can use this interpretation to understand that we have the distance from negative 5 is three. So we can center around the negative 5, and 3 to the left would be negative 8, and 3 to the right would be positive 2, or negative 2. So our solutions are -8 and -2. So this type of reasoning is what we will use to solve all of our equations. Notice that in most of these problems, we have two answers. We have the answer moving to the left, and we have an answer moving to the right. Now, the way that I solved these problems is to use the graph to give us an idea of what the answers are. However, that isn't actually how we solve equations, but this method, at least for the first page, gives us a understanding visually of how to solve problems. The way that we actually will solve problems is we'll take the absolute value bars and we essentially need to, quote, drop the absolute value bars. And the way that we drop the absolute value bars is we consider the fact that there are two answers, right? It's the expression inside of the bars is equal to the, quote, left answer, which is denoted by -3, and then the expression inside the absolute value bars is equal to the right answer, which is denoted by +3. So notice we take the expression inside of the bars and we set it equal to the negative version and we set it equal to the positive version. All right, a negative version and a positive version. And then we solve for x individually in each chunk. Okay, so let's go ahead and see what that looks like. But here's an important note that needs to be made. Before creating two cases, the absolute value bars must be isolated. And we're going to box that and put a star next to it and a sad face and an angry face. It's really important. So what do I mean by that? Well, in exercise 4, we have the absolute value equation. Absolute value of x minus 4 minus 10 equals to -2. So up above, I just told you before we split it into the two potential cases, the absolute value bars must be by themselves. So here's my absolute value bar expression, and notice that there is this -10 on the left-hand side. Before we split the equation up, we need to get rid of that -10. So what we'll do is we need to add 10 to both sides first. Doing that gives us the absolute value of x minus 4 equals to 8. And now that the bars are by themselves, we can consider the two cases. We'll consider the negative case, and we'll consider the positive case. Right? It's the splitting into two cases that allows us to, quote, lose the absolute value bars. And from here, we solve for x. So adding 4 to both sides gives us x equals to -4. And then adding 4 to both sides for the right expression gives us x equals to 12. So this means that our solutions are -4 and +12. So I can draw a quick number line and show that the solutions are -4, +12, and that's it. Right? It's not the numbers between -4 and 12. The answers are just -4 and +12. And we can check our solutions for this problem. So if I plug in -4, well, this turns into the absolute value of -8 minus 10 equals to -2. And then what is the absolute value of -8? Well, negative 8 is 8 away from 0. And then we have negative 2 equals to negative 2. So notice that negative 4 is a solution, because when we plug it in, it's true. In the interest of saving time, I won't check 12, but the check would be the same. Okay, moving on to number 5. We have 2 times the absolute value of 5x minus 1 plus 6 equals to 28. So just as before, our goal is to ultimately get rid of the absolute value bars. But we can't do that until the absolute value bars are isolated. So in this problem, first I need to get rid of this negative 6, or this positive 6, by subtracting 6 from both sides, which gives me 2 times the absolute value of 5x minus 1 equals to 22. Next, the bars still aren't by themselves yet. We need to get rid of this 2 in the front, so we'll divide both sides by 2, giving us the absolute value of 5x minus 1 equals to 11. And now that the bars are by themselves, we can then drop the bars by considering the positive and negative cases. So we have 5x minus 1 equals to negative 11, and 5x minus 1 equals to positive 11. Adding 1 to both sides gives us 5x equals to negative 10. Dividing both sides by 5 gives us x equals to negative 2. Okay, that's our first scenario. Second scenario, the work is going to be really similar, giving us 5x equals to 12, and then dividing both sides by 5 gives us x equals to 12 over 5. Okay, so my solutions are x equals to negative 2 and 12 over 5. And if we wanted to graph this on the number line, we simply need to plot the points negative 2 and 12 over 5. Okay, one more problem. So there are 2 special cases that we need to consider. So in exercise A, we have absolute value of 3n plus 4 plus 2 equals to 2. So just as before, we want to get the bars by themselves. So subtracting 2 from both sides gives us the absolute value of 3n plus 4 equals to 0. And now that the bars are by themselves, we can split into the 2 cases, right? Well, we have 3n plus 4 equals to negative 0, right? That's our negative expression. And 3n plus 4 equals to positive 0. But the thing is, this is kind of redundant, because negative 0 and positive 0 are really the same number, right? So the point of this example is to understand that while normally absolute value bars will have 2 answers, this is a special case, because when the absolute value is equal to 0, there's only one case, because negative and positive 0 are the same number. So we could then solve this, giving us 3n equals to negative 4, and then dividing both sides by 3 gives us n equals to negative 4 over 3. So this is a special case because we have absolute value equals to 0, and there's only one scenario then. Okay, in part B, we have 3 times the absolute value of x minus 8 equals to negative 6. Just as before, we need the bars by themselves before we split it into 2 cases. So we'll divide both sides by 3, giving us the absolute value of x minus 8 equals to negative 2. Okay, so from here, the temptation is to write the absolute value of x minus 8 equals to the negative version and the positive version. But there's a problem here. if we think about the definition of absolute value, this is saying the distance from positive 8 is negative 2. Right? This is how we interpret it based on the first page. The issue is, what does it mean to have a distance of negative 2? See, distance is defined to be as positive, right? You don't say you walk 5 feet, you don't say you walk negative 5 feet to 7-Eleven, you just walk 5 feet to 7-Eleven. So in this case, whenever the absolute value equals to a negative number, there is no answer, because there is no math interpretation for an absolute value being negative. So, absolute value cannot equal a negative number. No solution. And that's it for absolute value equations.